So a funny thing happened at my golf club yesterday. Well, I think I've told you before, I'm an avid golfer, but so we play indoor golf simulator during the season. But they gave me for my birthday, they gave me 2 coupons for a cocktail of your choosing. So I mean they were not very specific, right? So I first invented a drink known as the Mega Pint. Which is a half bottle pour of wine. And then I redeemed said coupon twice. Well, that drink has technically already been invented because I was the celebrity bartender there. I don't know, 2 months ago or something like that. That was my drink of the night, was the Mega Pint, and that came with free Uber rides. San Simeon. It's Cabernet. Yeah, red wine. Port. That's very, very biblical of you. Well, you just do it like an after dinner thing. Yeah. Well, I mean, port's like almost a syrup. No. Like people don't just sit there and like sip on like glasses of port like as with dinner. It's a yeah, right. You might as well do shots. Might as well do shots at that point. All right. Let's see here. All right. I'm sharing my screen here. Okie dokie. All right, so at the end of class last time, we had started getting some Java code running and crap, right? And we talked about some textbooks, they'll say something like pointers don't exist in Java, yada, yada, yada. But pretty quickly, I think we saw that pointers do exist in Java. We decided that what's a pointer? A pointer is a variable built for holding a memory address. So I just printed out the value of this variable AR, and it looks like a memory address, hence pointers exist. What we don't have in Java is we don't have a specific syntax for working with pointers, for working with memory like we did in C++. And by the way, related to this, if you were on Slack this morning, Emily Sear posted in general a link to a bunch of kind of like coding quizzes, but they really test your knowledge of different languages. So one of the things like I teach in class is programming is the skill set, the language doesn't really matter. But like last class, I said it's pretty important that you kind of give yourself a working program in these different languages right from the get-go. So that's why like memorizing the Hello World program is kind of important. So understanding those little nuances between languages. So as an example here, if they were to show you like, what is the correct way to display the value at a certain place in an array or whatever in Java, and they asked the same question about it in C++ or something like that, or they showed you some syntax in C++, you might have to be able to read that syntax with the asterisks and that stuff, or calling functions maybe with that arrow where it's dereferencing a pointer, right? But that doesn't exist in Java. Java removes those syntaxes, and from our perspective, we can kind of think about it as it kind of decides what we probably want it to do. Because most of the time, close to 100% of the time, what we want to do is pretty clear, right? Only when you're trying to do something really funky. And that's kind of why like hackers use languages like C and C++, because it lets you do some manipulative stuff that really isn't something you would commonly do. It's just something you technically can do in that language, where Java removes that from you. So part of it is Java does add some security layers that don't exist in C and C++. Part of that comes with your program running inside of a virtual machine. It's not even running directly on top of the hardware. It's running on top of something that maps to the underlying hardware. So one of our courses here, CSC450, is systems programming. And that's kind of the programming side of CSC350, which is the operating systems class. And so one thing you do in the 450 class is you write software, usually in C, for interacting with the actual operating system. And sometimes that has to do with having your program, which is running in user space, talk to stuff on the operating system that's running in system space, or root space, administrator space. That would be something that would be not very easy to do. Actually, you can't do it in Java because you're too many layers removed from the core part of the operating system, from the kernel. Whereas C, there are specific system calls built into the language, built into the operating system, that allow you to, with the correct permissions, have your user level program talk to some kernel level stuff on the operating systems, as long as you can validate yourself. So those would be kind of dangerous C programs where Java pretty much doesn't let you run a program that could majorly do damage to your operating system. Probably the worst they could do is like overwrite a file or something like that in your own directory, or a directory you have rights to. You maybe can do something with some network stuff, but you can't get into too much trouble with Java. And even modernly with C and C++, most of the runtimes run it inside of a little bubble, whether it's officially a virtual machine or kind of a segregated part of memory. They run it in there to kind of protect you from yourself, so you can't have programs that require you to reboot your machine. I think probably told you last semester, years and years ago, it was very common where you'd be writing a program, and now like last semester you would have a situation where you like had some kind of pointer problem, and then it would kind of tick you off with online GDB, because sometimes it wouldn't give you a error, it just wouldn't work, give you a blank or something like that. Well, the common error you would get in a traditional runtime would be something called like a segmentation error. Well, those are the friendly versions of it, even though it's not meaningful at all. Back in the day, what would happen is your computer would just crash, and then you had to just restart. Hopefully you saved your file so you can go and fix it from your last save point, and you just have to keep going from there, because your bug actually made you have to reset your operating system because you corrupted memory or did something not so hot. All right. Look to hello world. Pointers exist in Java. Let's just roll. All right. So we had our dungeon crawler, right? All right, and our dungeon crawler, we had we had our dungeon, right? Our dungeon was a collection of rooms where one room was a starting point. I think that's how we had written it, right? Okay, we had a room, so I'm kind of, we're deciding on who our players are in our play, in our scene. I'm starting to use a little jargon from Unity that we're going to run into in after about a month or so. All right, because Unity, basically every screen of your program, it calls a scene. All right, so you have the actors that are in your scene. So what do we have involved in our dungeon crawler? Well, we got a dungeon, and our dungeon has a whole bunch of rooms inside of it. So a room is a collection of inhabitants. Actually, I think last semester we had players and we had monsters, right? That's how we kept it, right?
We didn't get to monsters.
Oh,
We didn't do monsters.
I thought we put a rat in there. We never put a rat in there. Oh man, you guys missed out. We'll do it pretty early on here. All right, so we're going to say, I'm going to put in here a collection of inhabitants, because pretty early here, we're going to start introducing, we're not just making a duplicate of what we did last semester, we're going to start introducing some additional object-oriented things. We at least mentioned that last semester we talked about inheritance, where you can have a generic class that then other classes inherit from. So we're going to have this idea of things that inhabit our rooms, where an inhabitant can be a player or it can be a monster, something like that. Okay. And they both have a lot of commonalities, but then they have differences in and of themselves. All right. Well, I probably mentioned the word at some point. Now we're going to talk about it. Yeah. No, we'll talk about it here. All right. So a room is going to be a collection of inhabitants and exits. An exit is a two-way door between two rooms. I don't remember. Did we do exits last semester where a room had an exit going out and another exit coming back in instead of a single exit that was two-way? Okay. Do we want to do it the other way this time? This is the other way. Yeah. So do we want to do this the other way this time? Same way? Okay. An exit is a door leading to another room given a direction. All right. An inhabitant is a player or monster that inhabits the rooms and can potentially move around. So players are going to move around under our control, right? And something we're going to look at here pretty quickly is monsters. They might move around under the computer's control. We're going to do some multi-threading stuff where the game kind of has this heartbeat, or maybe every second, for example, you know, maybe a rat has a, you know, he rolls a random number and decides, do I leave this room or not? Something like that. And which direction do I go? That way your dungeon starts feeling alive. While you're standing there and all of a sudden a rat wanders in, and he could be a really mean rat where he wanders in and immediately attacks, right? That kind of stuff. All right. So we'll add a couple of things like that in there. And that idea of multi-threading is a pretty important part once we get into Unity. Unity has effectively things that occur every single time there's a new frame. You know, when we think about the speed of you know, so at some point we talked about like graphics cards and things like that, and super more expensive graphics cards, they let you do more frames per second, right? For your game. So the idea is that, let's say you have a game running at 100 frames per second. That means 100 times per second a new frame is being created, which is an opportunity to have something change on the screen, right? Maybe move, maybe have something happen behind the scenes, whatever. That's happening behind the scenes in something called a thread. All right. And that's where having multiple processors and things like that start coming in, because if you have a single processor with one core and it's trying to pretend to be doing a zillion things at once, at that point you start getting some sluggishness and things like that. But threads allow us to have multiple parts of our program behave at the very least as if they are happening independent of each other without blocking each other. Where we could be in the middle of typing that we want to move to the north when a rat wanders in. You know, that us interacting with the game doesn't prevent some other aspect of the game from still happening, because it's happening in its own thread of action, thread of activity. Okay. So we'll play around with some thread stuff here relatively soon. All right, so we have dungeons, we have rooms, we have exits, we have inhabitants, where an inhabitant is a player. So human controlled with a name. We're probably going to throw in like a number of hit points. Let's just start off with a name. Because the idea is eventually, you know, when we have these rats running around, we're going to have to, you know, clear the dungeon, right? You know, it's a thing. Maybe we'll throw the tag team Dr. Locklears as like a boss fight. Well, years ago, we could just say Dr. Locklear. That was before Josh started working here, and now Josh is Dr. Locklear as well. So now you got to do the old and the young or something like that. Well, now we'll just have them be almost like a two-headed monster. But we'll have to give ourselves like a power move, some kind of magical attack, chaos bolt. All right. Human controlled with a name. Monster, we'll just say computer controlled with a name. Initially, we won't build in that deathmatch interaction, because remember last semester we also wrote this deathmatch thing, so we're kind of bringing those pieces together into this whole thing. But we'll keep the bloodshed to a minimum initially, but we'll, obviously it's a course requirement, so we will certainly get that, we'll get that interjected relatively soon. Oh, it's everything. Yeah, right. That's it. And it's makes us stronger. All right. Am I missing anything? Do we at least have the core stuff from last semester? All right. So let's start creating some of this stuff as our base in our game. So we'll look at it kind of by example. Am I at least logged in? I am. So I'm going to create a new project. And I picked Java. I'm going to go ahead and save this project. And we're going to call this guy Java Dungeon Crawler Spring 2023. Good enough. All right. I think we saw last time that online GDB requires that this first class be called main so that it can behind the scenes make its thing work. Okay, but the only thing that's actually required in Java is that your function where your program starts, all programs begin and end with main, is called main like this. You can rename the variable here args, but it has to be a string array. But the name of your class just has to match the name of your .java file. But online GDB didn't let us change the name of this file. So we're kind of stuck with a main.java. I think I mentioned last time that typically what I'll do in Java, my naming convention is I name the class that has the main method in it, I call it driver, because it's the thing that drives our program, since all programs begin and end with main, just that kind of jazz. All right, we'll run this dude real quick. Make sure we get a hello world spit out there. Okay, everything seems to be working. So now we're ready to start developing, right? All right, so go back to our little plan here. So we got a dungeon, we got a room, we got an exit, we got a player, we got inhabitants. Let's go ahead and make a player first. How about that? All right, fairly simple little class. So I'm going to create a new file. We're going to call this guy player.java. Okay, and this guy's going to be a class player. All right, now when we were doing this in C++, we had a public section and a private section and things like that. I think we had done everything under the public section, right? But you had this little thing in here like public like that, and then we put stuff underneath that. That does not exist in Java. In Java, instead, what we do is we put that security keyword, we associate it with each field and method that's in there. All right, so we don't have like a public section. Instead, a class is just a collection of, just like last semester, what are things that live inside of a class? What are our three, and what are the variables called when we're talking about object-oriented stuff? Fields. Okay, so we have fields. Those are our variables. What else? Constructors and methods. All right, so classes are filled up with a collection of 0 or more fields, 0 or more methods, and technically we can say 0 or more constructors, because if we don't provide a constructor, one will be provided for us. I'll show you that here in a second. And the same thing was true in C++. We might have just not talked about it specifically. So technically, that's a complete class, my class player. All right. So notice a couple of things here. I don't have the little semicolon there at the end of it that we had in, I think it actually probably wouldn't hurt anything, that we had in C++. Notice I also don't have the header file and the CPP file. Right? Doesn't exist in Java. Instead, because the idea, why did I say that header files were actually good? What was my argument? Even though Java didn't, or C++ didn't absolutely require header files, but header files were a very common and historically sound thing. Why are header files good? Good. Okay, so it kind of self-documents your code, right? Because presumably, as you start writing more and more complex programs, your .cpp file is going to get pretty, there's going to be stuff in there, right? Where your header file doesn't have any of the implementation in it. Just kind of tells the story of all the stuff you're gonna have, right? Okay, so it's a nice way of looking at a header file and just kind of getting at a glance what stuff's involved in this class. And then you dive over to the .cpp file and get the nitty-gritty of how it actually plays out. Make some sense? All right. Well, Java doesn't have that. So in the early days of Java, the idea was Java had something built into it called Java.doc. All right. So if we go, well, I'm already in a browser, right? Let me hide this dealy flippy. How do I do that? Hide floating meeting drills. There we go. So if I do Java documentation, I don't care what version we get. Here, Java platform SE7, that's good enough. Okay, probably the newest one is 10 or 11 or 12. I haven't kept up, but this format we're seeing here, this is what Java.doc creates for us. All right. So on the upper left-hand corner, you have all of the classes. So right now we're looking at the entire collection of classes that come with the core Java programming language. That's a lot of packages, a whole lot of stuff. There's a core one called java.lang. That actually has gone away now. Now I think it's Java core, but I think java.lang still existed in 7. Yeah, so here's java.lang. This is actually what you get when you launch a Java program and you don't import anything special. This is what comes with your starting point for Java. So you see in here, we have a bunch of classes. We have Booleans, bytes, characters, yada, yada, yada. We have strings are going to be in here. We're going to have our stuff for reading things in from the user. We have threads, what we're going to talk about this semester. So it kind of gives us a bunch of the crap that we might want to commonly use in our programs without having to bring in other packages. Okay. That's more just trivia on the side stuff. All right. So now if I click on one of these, let's just click on strings, because pretty quickly here, we're going to be using strings because our player is going to have a name and that's a string, and strings, just like in C++, strings probably can do some stuff, right? Report their length, that kind of jazz. All right. So let's click on string. So if we were to use the Java.doc syntax, which we're not going to do, because we're lazy, and I haven't done it in years, so I don't want to do it. Those combination, nobody does it anyway. So this is, I'm not breaking what you're going to do in industry either. Okay, it'll give you something that looks kind of like this. Here's your collection of fields that belong to the string class. Here's all of the constructors. These are all the different ways you can build a string. Okay, then we have our method summary. So here's all the methods that are built into the string class. And these are all the core ones. We also then get methods that are inherited from something else. Okay, we're going to talk more about this as we get into it, but just like in C++, even though we didn't focus on this aspect of C++, all object-oriented languages, they have a core top-level object usually called object. Sometimes it's a capital O like it is in Java. It's a lowercase o in C#. I think it's a lowercase o in C++, but whatever. So you have, this is the most generic of objects. This is what it takes to be an object. All right. and it has some stuff that are just part of this, and like this notify method here kind of works with threads. We'll talk about that a little bit. But these are things that are built into what we're going to be talking about, this toString method. This deals with some of the special stuff in some of the new things that are added into Java. But every single object that exists in the Java language at its most primitive core is an object. And then it might have, through inheritance, might have other abilities that have been slated in there. Now, a string is only one level removed from the core. So if I go back here, I think it even shows at the very top. Here's our class string. A string only comes from object. All right. And something we're going to get used to doing here over the next couple of weeks is reading the Java documentation. That's the skill that we want to have. And I'm going to, take that a step further. We need to know anything about a language that we're just learning. We need to know enough to be able to accurately read the documentation. None of us are going to go and memorize these entire languages. Okay? I've been programming in Java since literally the day it came out, somewhere in like 1994 or something like that. Okay. Do you think I know the entire language, every single class, every single method, yada, yada, yada? Okay. I've probably at some point in all those years used 10% of the language, would be my guess. If you look at some of the classes that exist, it's got some stuff for some really rare, very, math, whatever, built for some very specific scientific simulation or something like that I would never mess with, so very small percentage of the language. I've probably worked with all of the stuff that lives inside of java.lang at some point, right? Okay, but there's no way that any human being memorizes every last little thing in the entire programming language. We kind of have our core group of things that we use all the time that we probably don't need to go and look at the documentation for. And then we might have some things that, hey, I know that exists. And you know what? It sounds like there probably is a method in class XYZ that probably does what I want it to do. Let's go and glance at the documentation real quick and just see. And this guy also tells us how to use it. All right. So being able to read the documentation gives us the power that we need to be able to do our jobs. No employer is going to expect you to memorize every single thing that lives inside the language. But you do need to be able to go and get your answers when you need them. All right, makes some sense? So reading this documentation is very important. All right, so a class is almost a generic object. It just has a couple of other things built into it that make it a string instead of a generic object. Just like in our program that we're kind of designing here, a player has a couple of things that make it a player instead of just an inhabitant. And an inhabitant is going to have just a couple of things that make it an inhabitant instead of a generic object. So we have object, from that is going to be an inhabitant, from that is going to be our player and our monster. Okay, monster is going to have a couple of things that differentiate itself from inhabitants. But a monster is still an inhabitant. He's just a little bit more. Okay, we're all inhabiting this room. Okay, but we're all also humans. Okay, and there's something unique about humans over and above just living thing or something like that. All right, so we scroll down here and look at our method summary, and here's a bunch of stuff that strings can do, and we're going to look at several of these. Charat, super common one. Not really concat. We use the plus symbol for that. We have contains. We can find out, does a string contain a substring? We can ask if a string ends with a certain thing. We can ask if a string equals another string. We'll look at these things. We can see if it equals another string, but ignore case, upper and lower case. We can use index of. That's another common one. We're going to look at that here pretty quickly here. We can find out what the last index of, in case index of gives us the first time something is found in the string, or -1 if it doesn't exist. In fact, I think we wrote index of last semester, right? I think we wrote that method to work with our C++ strings. It's built into strings here. That's why I named it index of, is because Java calls it index of. A string can report its length. We can replace one character with another character in a string. We can replace like substrings, like a sequence of characters. We can replace all occurrences of LOL with something else, not just a single character. We can split a string based on a regular expression. We can, so we can get a substring starting from a certain place in a string. We can convert a string to a character array. We can convert a string to all lowercase. We can convert a string to all uppercase. We can trim a string, which takes all white space from either end off, giving us just the string. It won't remove spaces in the middle of the string, though. So if you have a sentence, but a bunch of white space on either side, we can get rid of that white space real quick by just calling trim. And now you have your sentence with all the spaces inside of it preserved. That's the highlight reel of strings. Several other methods in there, but what I just described are things that you might actually use on some sort of common basis, with the super highlight being length, char at, and index of. And maybe split. Splits, as you write a little bit more complex stuff, split's pretty handy. Okay, but the punchline here is that the Java doc produces a format like this. So if you were to be writing a library for work or something like that, and you chose to add the Java doc format into it, when you're done, if you ran the Java doc tool on your classes, it would produce HTML files that have this format, that somebody else at work can go and just look at. Here's your classes. This is what each method does. This is how you call it. So for instance, to uppercase takes no parameters and returns a string. We know that this guy is an instance method because he doesn't have the word static out front. We're going to really drill that home here as we talk about it here in Java. That's I think last time that word static was brought up for the first time, and I kind of mentioned that this guy's an important thing, but it doesn't go very deep. If something's static, it belongs to the class. If something's not static, it belongs to an instance of the class. So we call to uppercase on instances of the class, and to uppercase returns a string. We call, value of, for no good reason, I guess, on, and this guy requires a long for us, and we call that using the string class itself, string dot value of. We can pass it a big number along, and it'll give us the string version of that. We never use that because we would just do it with concatenation. All right, and we will drill that home, what I just said. That was just the kind of the outline, out loud, quick version of it. Okay. But anyways, this is the format Java doc gives us, and it's a nice way of documenting your stuff. But most of our modern day IDEs, what they do is they allow you to, there's usually a little arrow that allows you to collapse a function. So all you see is the function header, just like we're basically seeing here, without all the implementations. You might have 1,000 lines of implementation, but you just kind of minimize the method having just the header. And if you needed to look at the stuff inside of it, I think Online GDB has it, so we'll look at here in a minute. But in any case, so you can kind of create your Java files just to be self-documenting anyways. So very few people actually use JavaDoc, but this was put in there in 1994 because it was thought to be a good idea and thought to be the replacement of header files. All right. Yeah, so for instance, here with main, well, here's our main method. I can hit this little arrow right there, and it just minimizes the method. So I could have a 10,000 line program that has 8 methods in it, and I can have it turn into 8 lines. which is effectively documenting itself, especially if you put a little comment before the method saying this is what this dude does. All right, so let's explore strings just a little bit since we just kind of looked at the documentation. I mentioned here that this could be the simplest player class. And so let me finish that thought here real quick. So if I want to create an instance of player, I say player P is equal to new player. We create instances of objects just like we did in C++, right? This just looks pretty similar to us. But now one thing I want us to notice is if I go into the player class here, notice we did not write a constructor that takes no parameters. We basically just wrote class and left the rest of it blank. That's a legal class. It's a useless class, but it's a legal class. It says what? Correct. There is actually probably a world where you can actually make it do a little bit more than nothing. If we created our inhabitant class to be just like this, and then we created our player class to extend inhabitant and our monster class to extend inhabitant, but didn't put anything in them, we could technically then create an array of inhabitants, fill it up with players and monsters, which don't do anything in and of themselves, but we would then be able to use the instance of operator to determine is something a player or something a monster, even though they have no substance to them. So it lets us do something that's almost useless, but technically it's more than just runs. All right, and we'll see all that, so you didn't have to follow what I just said. If you correct. Not that you never have to do it, but what you're talking about is really linking your C++ and header files. You now have to do that. And more so, really what he's talking about there is in C++, I would have had this class called player, whether it was in a header file or whether it was in a CPP file. Typically inside of main, we would have had to include player.hpp, right? No, it knows about it as long as it's in the same package. Right now, we're using the default package, which effectively says if it's in the same directory. Okay, so yeah, it just knows about it. And wouldn't that be nice? Because remember, last semester, we had that situation where we kind of had to fight with that situation where you had one class that knows about another class that also knows about the previous class. So you created like that infinite loopy thing in it, right? So you kind of had to do like the little hacks to make it like fake it so it would compile, but then at runtime, because you know all the linking had already occurred, just assume that, okay, it's going to know about the real deal by the time we go to run. It's gone in Java. Like, just works. All right. So we have our player P, and I'll go ahead and print out P. What do we expect to print out here? Would have been the same answer last semester. Good. Memory address. Several things point that out to us. What's the main thing that tells us that we're very likely going to get a memory address here? Yeah, new keyword. Remember, new keywords are real estate agent. So whenever the new keyword's involved, memory is being created. Pointers are happening. All right, pointers are happening, even though we don't have the syntax for them, but they're happening. So P is holding the result of calling the new keyword on the player constructor that we didn't write, but that technically exists. All right, so I'll go ahead and run this and we'll see our address for our player. Kind of notice how, yes, we get the little freaky deaky hexadecimal addressy thing, but notice in Java, it's always preceded by something. This says player at that address. If you remember for like an array last time, it had the little square bracket. Okay, because Java is kind of creating their own fake memory because it's running in a virtual machine that lives on top of real memory. Okay, this is still a memory address. It's just not directly given to us by our actual operating system. It's given it to us by our virtual operating system, which is the Java virtual machine, which knows how to talk to the underlying operating system, which isn't our business. You know, we can only do what Java lets us do. Okay. So this guy works just fine. But notice I didn't actually write that constructor in there. So if I want to go and write a constructor in there, and just like in C++, the constructor has to be called the same name as the class. We'll have this guy take in a string name. And for right now, we'll just print out that name. For no good reason. All right, so now I have written a constructor into my class, and this constructor takes in a single string name. And then all he does is prints it out to the screen for no good reason. So now when I come back to main and I run this, now I'm going to get an error. Notice I'm calling that no argument constructor. That existed a minute ago, right? It only existed because I didn't write a constructor myself. Now that I have written a constructor, it's no longer going to go and provide me a no argument constructor just to make this syntax work. It's going to yell at me and say, hey, there is a constructor in this dude, and you didn't call it right. All right. Can't be applied to nothingness because this constructor requires a name, a string. So I'll go ahead and pass in a string to that dude. So now I'm calling the constructor the correct way. This constructor for this class takes in a single string as a parameter. And then what do we expect that constructor to accomplish as part of this? Well, constructors are supposed to initialize the object. This guy basically just does a song and a dance and just prints it out to the screen for no good reason. So now, during the construction of my object, Mike is going to get printed to the screen. And that actually happened inside the constructor. All programs begin and end with main. So when I run this program, we start at main. It hits first line of main, and this guy creates a player. But as part of creating that player, the constructor is going to say, oh, print something to the screen. Then I'm going to print out the value of P. Is that guy still going to be a memory address? Yep, still a memory address. All right, so there's our Mike, and there's our memory address for that dude. All right, questions about that? All right, so before we start adding any more to our players, let's explore strings just a little bit since we're going to be working with a string inside of player. So right off the bat, we're going to break our own rule. So I'm going to say string S is equal to hello. String S2 is equal to new string hello. String S3 is equal to hello. You will very, 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 very rarely ever see someone build a string this way. Even though literally every other kind of object that either comes with Java or that you create yourself, in order to create an instance of that object, you must use the new keyword. I often will say Java is a string-based language. If you can get something in the format of a string in Java, it's very malleable. You can turn it into almost anything else. So because of this, Java has a special syntax reserved only for strings that allow you to treat strings as if they are almost primitive types like ints and chars. So you can quickly create a string by saying string S is equal to hello like that, and you don't need to actually use the new keyword along with the constructor, passing it the string and letting this guy build it. That make sense? So we'll go ahead and print these three things out, system.out.println. S. S2, S3. So what do you think? Are we going to get hello printed out for all three of those? So right now we're kind of going through an exercise that I talked about from last semester, that before we run a program, we should look at it and try to determine what it's going to do ourselves. Okay. Now, a few minutes ago, when we created our player and we printed out the player, we said that it's going to be a memory address, right? And I asked why. And it said, and I portrayed it as, oh, because the new keyword was involved. If you remember, I said, it's very likely if the new keyword's involved, you're going to get a memory address. So if we operate only off of what I said before, we should get probably hello, memory address, hello. But we won't. We're going to get three memory address or three hellos. All right. So there's our three hellos. Now it gets even trickier. The reason for that, I'll throw out the reason for that, but we're not going to explore it yet. The reason for that is a method that's built into the object class called toString that the string class overrides. And the string class's toString method says just return the string version of this object, which is hello in this case. Whereas for object, the default implementation of the toString method is the memory address representation of that object. So if you write your own objects, like we're writing a player here, our player we saw had a, if I do a println P here, we saw we got a memory address from that guy. There's our player's memory address, right? It's because if we look at player, we did not write a toString method in here. So it inherited the object's version of toString, which does the memory address thing. If instead I say public string toString and I return LOL, now all of a sudden it won't be a memory address. It'll say LOL. Whoop. Not, capital S in this language. Strings in Java are capital S's. So there's our LOL instead of the memory address, right? The default toString method that comes with object, it has that memory address thingy. If you choose to override it with strings did, it gets something better. Okay. Man, I haven't given you enough to. All right, I'm going to. Enough. We're going to threaten a quiz for Monday, dealing with the things we talked about during class today. So the intro stuff with strings, the intro stuff with objects, the constructors. I won't go back to some of the history stuff. I might ask about the how header files have now been replaced, something like that. So make sure you study your notes from today in preparation for maybe a short 5-minute quiz at the beginning of class on Monday. Sound good? All right. Pretty quickly here, you'll be able to get your first programming assignment. Yeah. Just basically the stuff when we just started rolling into object-oriented Java stuff. And I'll definitely try to trick you so you miss points by default. All right. Have a good weekend.